Respected Director, Guest of Honor, beloved lecturers, and delightful students. On behalf of the Department of Computer Science, School of Computing Sciences, Vels Institute of Science, Technology and Advanced Studies, warm welcome to everyone for the national webinar on First Step Towards Data Warehousing. We like to express our sincere gratitude to our management for their constant encouragement and continuous support for conducting these type of webinars. It is an occasion we get opportunities to test our knowledge and understanding. I am glad to invite Dr. S. Sarada, Assistant Professor, Department of Computer Science, Vistas, to welcome the gathering.
Good morning to all of you. Welcome every morning with a smile. Look on the new day and as another special gift from your creator. Another golden opportunity to complete what you were unable to finish yesterday. Today will never happen again. With these beautiful quotes, I am Dr. Sharada, Assistant Professor, Department of Computer Science, here to give a welcome speech. It is my pleasure to welcome you all for this webinar, First Step Towards Data Warehousing, organized by Department of Computer Science, School of Computing Sciences, Vistas. On behalf of Department of Computer Science, I cordially welcome the eminent speaker, Mrs. T. Alamelu, Director, eshipz, Bengaluru. At this moment, I am very happy to share that resource person, Mrs. T. Alamelu is very good friend of mine. Welcome you, ma'am. I extend my warm welcome to our beloved Director, School of Computing Sciences, and Professor and Head, Department of Computer Science, Dr. P. Mailvahanan, faculty friends of various Department of Vistas, and my dear friends. On behalf of Computer Science Department, at this time, it is my duty to extend our profound gratitude towards our respected founder and Chancellor of Vistas, Dr. Aisari K. Ganesh, Pro-Chancellor PND, Dr. A. Jodi Murugan, Pro-Chancellor Academics, Dr. Aarti K. Ganesh, Vice President, Ms. Preetha Ganesh. Also, we wish to express our heartfelt gratitude to our Vice Chancellor, Dr. Sriman Narayanan, Registrar, Dr. P. Saravanan, COE, Dr. A. Udayakumar. Once again, I welcome you all. Cherish your knowledge. Have a great day. Thank you.
Thank you, Sharda ma'am. It is my privilege to invite Dr. T. Stikala, Associate Professor, Department of Computer Science, Vistas, to introduce our chief guest.
Very good morning, one and all present here. I start with a quote: more powerful than the will to win the courage is to begin. Success is not final, failure is not fatal. It is the courage to continue that counts. It is my pleasure to introduce the eminent speaker, Alamelu Vyagarajan, Director, eshipz, Bengaluru, for this session. I am sure that this will be a nice and informative session. She has around 11 years of experience in the field of information technology with special focus on EW technology. She completed her UG degree, BSc Chemistry at St. Mary's College, Tuticorin, with a distinction at 2001. She has completed her PG degree, MSc Computer Science at Tyagarajar College, Madurai, with a distinction at 2003. She passed the degree, Bachelor of Education, with a distinction at Om Shanti College of Education, Chennai at 2017. She received rank certificate from Tyagarajar College, Madurai. She got university third rank in English. She received university 8th rank in chemistry. She received the award of best outgoing student at UG level. She obtained merit certificate from Government of Tamil Nadu for SSLC. She was a project trainee at Polaris Software Lab from December 2003 to April 2003. She worked as Senior Software Engineer at Informatica Business Solutions from April 2003 to July 2007. She worked as Technology Lead at Infosys Technology Limited from July 2007 to April 2010. She implemented project for a leading healthcare client in US. He worked as manager at Cognizant Technology Solutions from April 2010 to November 2014. She has implemented projects for a leading retail chain and a leading manufacturing client in US. She is a volunteer teacher with E-Vidya Loha since 2018 to Jan 2021. E-Vidya Loha is a non-profit organization that creates digital classrooms for children in remote village. You have done a great job, ma'am. His expertise in providing data integration testing solutions with strong hands experience in Informatica and Teradata. He is a good worker with the ability to adopt new technologies coupled with proven capabilities to work in both independent and team-oriented projects. As she was worked both in teaching and industry field, I hope this will be a interesting and very knowledgeable session. We are eagerly waiting for your session, ma'am. Thank you.
Thank you, Srikala ma'am. It will now be the turn of our chief guest, Mrs. T. Alamelu, Director, eshipz, Bengaluru. Ma'am, now the time is yours.
Thank you, one and all. I would like to take this opportunity to thank the esteemed faculty of Vels and also thank Dr. Sharada for providing me an opportunity to present this in the midst of all students. And it's nice to be back in this environment again. So let me start my presentation. And so the agenda of this meeting or a webinar would be to take you into the world of data warehousing, the small baby steps that you need to enter into this world.
Excuse me. Alamelu, ma'am.
Yeah.
The screen
Yeah.
is not visible here. We couldn't see your screen.
Just a minute.
Oh, okay.
Is it okay now? Ma'am, are you able to view?
No, ma'am, no. We can see only the black screen.
I'll try to present again. How about now?
Yes, ma'am.
Okay. Sorry
It
for
is
that.
good. Thank you.
Yes, ma'am. Yes, ma'am.
Sorry for that, guys.
Oh, yeah.
So the agenda of this session is to enable you to understand what a data warehouse is and help you make that small baby steps in understanding the concept and if need be in venturing into data warehousing, and because the future is that of the data. So you all might be knowing about data and information, right? So what is data? Data is nothing but facts. And what is information? Information is nothing but data when coupled together gives you some information. Related, structured, filtered data forms a part of your information, right? And then what is knowledge? Knowledge is nothing but making use of the information and applying the human experiences to derive some decision out of it. So data contains unfiltered or it could be unstructured facts. Information is when you relate the data, you get some meaning out of it. Knowledge is information, but with some nuances, right? And based on the knowledge, you make some critical business decisions. So the understanding of data, information, and knowledge is very critical in the field of data warehousing. You all might have learned about this OLTP systems, which is online transaction processing systems, which we use in our day-to-day life, right? Like your online ticketing or your online banking, right? So if you think about the databases used in these OLTP systems, it would be mostly of relational databases earlier, around 1980s timeframe, right? So you had this RDBMS and you had like Oracle DB2.
Sybase and whatnot, right? We thought Oracle is the world those days. So the transaction data will always be stored. I'm hearing some background voices. Can you please go on mute? Yeah, thanks. Yeah. So coming again, OLTP is mainly on the relational database systems wherein transactions happen and you need daily updates of what is happening, right? So you withdraw an amount from your bank account, right? The systems needs to be updated with the latest balance. If I don't do that, then my system is in a total mess. So, but we needed something else as well, right? So say if a bank manager would want to decide whether he needs an ATM in a specific location, right? What does he need in that case? Data of customers who are using the banks, to withdraw their amounts from the accounts. So based on the customer usage, right, he will decide whether or not to have an ATM in that specific location. So this is what we call as just one example of a business decision, right? So to make all these decisions, we also need data, but we don't need it like as in a transactional database systems, right? So you will not be making decision in a single day, right? So over a period of time, so the history of data is more important when it comes to the OLAP systems. So now let us understand the difference between the operational and the informational systems. The operational systems are your OLTP systems and the informational systems are your OLAP systems based on which you make critical business decisions, right? So as I've already told you, the OLTP systems gives you the current representation of the state of business, while the OLAPs, it gives you a period of data on which you can, make your analysis. And for OLTP systems, the performance, the responsiveness is more important, right? So you can't wait for an hour or not even 10 minutes, to get your account details updated when you withdraw your amount. It has to be instant, right? That's how the OLTP system works. But when it comes to OLAP systems, it's okay. I can wait for some time, right? So I schedule my jobs over a period of time, okay? And the concentration is not just only on the performance, right? And in OLTP systems, you basically write some small or simple SQL queries to get the data out. And there would be constant updates as well happening. While in the OLAP systems, the queries will be a bit complicated because you will need to, aggregate the data, right, in order to make a decision. So the OLTP systems differ from the OLAP systems in the way the data is being used. Now, why do we need a data warehouse? It is because of this reason that we need to separate data that resides in the operational DBMS from the informational systems, right? So because of this difference, in the 1980s time frame, scientists thought about, separating these two databases and having an exclusive data warehouse for analytics purposes. So the data in the data warehouse will provide you integrated information about your organization's data, which is very critical. So now, what is data warehousing? The definition seems to be complex, but it is not so if you understand the meaning, right? So Bill Inmon is called as the father of data warehouse, and his way of defining a warehouse is a subject-oriented, integrated, time-variant, and non-volatile collection of data. As I said, why do we need this data? to make a decision, right? To help the management make critical business decisions. So when I say subject oriented, what do I mean? So it means that the data that I'm going to load in my warehouse, it would be of a particular area that would be of interest to me, or it would be of help to me. Say a sales warehouse data or a purchase data, right? Something of that sort. And when I say integrated, so normally data is not available in one single location for you to go pick it and then load it into the data warehouse. So data could be in flat files, data could be in your COBOL. I'm not sure if you have, heard about vSAM sources. Those days we had this COBOL, occupying the mainstream. So your mainframe files, or it could be your DBMS systems, or it could be even from your messaging queues, right? So data is available in a wide variety of environments from which you would need to collect the data, and then you would need to put in a central repository for the business users to analyze it. So that's what Bill Inmon meant by integrated. And time variant, meaning that all data in the warehouse, comes with a time period, right? In an OLTP system, I would not be bothered about, what a customer account was some 10 years back, right? But in a data warehouse, I would be bothered about, the history, so that based on the history only I can make decisions, right? So in any company, right, they'll be planning like 10 years ahead of future, right? So where do they get the data, right? So they will look into the past history, and then they will take critical business decisions based on it. So data always needs to be time variant in a data warehouse, and it should be a non-volatile, meaning data is never removed, right? Once it is into the data warehouse, it is always in it over a period of say 10 to 15 years at the max. So this is what Bill Inmon, the father of data warehousing, defined how a data warehouse should be, right? And we have another scientist, Ralph Kimball, who also came up with a relatively, easier definition, right? So as we discussed, right, a data warehouse is nothing but a decision support system that is maintained separately from the operational databases. So in the field of data warehousing, these two were considered as the gurus, and both have different methodologies of implementation of data warehousing. Moving on. So let us first understand what data warehouse means. Data warehousing, it's not like an out of the box solution that you get from anywhere and, just fit in your company and then you can make business decisions out of it, right? It is a process, right? It is a journey towards making some decisions so that, your company can be stable even after like 10 to 15 years, right? So what we do here, we get all the operational data, and then we load it into the warehouse, and then we make some reports out of it, which can be used by the business users. So you would have heard this terminology being used quite often. Whenever anyone talks about data warehousing, they also talk about ETL. ETL means extract, transform, and load. So as I mentioned you, extracting is getting the data out of different sources and then applying the business logic, right? Like aggregation or data cleansing. Cleansing is one of the most critical operations that we do, right? So the data that you take from different sources might not always be of, topmost quality. There is always a dirty data attached to every data that we get, right? So we need to cleanse the data, and based on our organization, there might be some business logics that we need to apply, and then we need to load data into a warehouse. So this entire process is called as extract, transform, and load. There are many tools available in the market to do this ETL process. So one more thing I wanted to, explain about DWH is, how do you understand this, right? So say if I have a store, right? I place bread packets in one row, in one corner of the shop, right? And I have my jam bottles on the other corner of the shop, right? So now, if I place my jam bottles next to the place where my bread packets are, right? There are, like 80% of chances that a customer who is buying the bread might pick up the jam bottle as well, or vice versa, right? So my business is getting doubled in this case. So how do I make this decision of where to put, which product? Everything is based on the data that you load into your data warehouse. This is just a very simple example for anyone to understand the data warehousing usage. It might appear as a complicated topic, but then the usage of this, if you understand it in simple terms, it will help you study the concepts of data warehousing with much ease. So, okay, getting into data marts. So why do we need data marts? Data warehouse of any organization will be very huge, and building it will take, enormous amount of time, and the maintenance of such systems also will cost you more. And there might be cases where the data that might not be of any relevance to one user is also available to the other user. And for security purpose also, right, we need not, display the data that is required for a sales department to your HR department, say, right? So what they did is they divided this data warehouse into small logical units, and we call them as data marts. Data marts were built, to reduce cost and to make the analytics more faster, and it would serve that specific set of users. And it can also be built in a lesser time frame. So here comes the DWH architecture. So data from different sources, right? It is being fetched, and it is, getting loaded into a staging area. So usually in this place, right, it will be, a plain dump of all the data into the staging area. Okay. And the next stage, right, from the staging area to the data warehouse, there the original transformation will happen. We'll be applying the business rules or the mapping logics, right, in this specific layer. And once it is loaded to the data warehouse, it will then, if necessary, it will, get separated into small logical units with what we call as data mart. And then the business users, right, will make data out of these data marts. Basically, there will be a BI layer there, which we call as the business intelligence layer, on which the reports and the dashboards will be built. So there will be a separate, team, which we call as the BI team, that would, make sense out of this data and build the dashboard and analytics for the business users to derive meaning out of it. So this is what has been the architecture until some time back, right? And now with the advent of the internet, everything is changing, right? You have your social media, Facebook, Twitter, right? And you have your streaming services, right? And we are getting more and more of data, right? So the data is actually more than what we actually think. So to cope up with this new challenge of data everywhere, right? There came the concept of big data. I hope you guys have heard about it, right? So this big data made problems more complicated for data warehousing, because as such, a warehouse can deal with the structured data, whereas in big data, we were getting unstructured data like your photos, right, images, and semi-structured data like your XMLs and stuff like that. And the data volume is increasing, right? Increasing at a rate that you can never imagine. And the cost of maintaining a data warehouse is becoming more and more expensive, right? So, and one more thing that came up is the cloud revolution, right? So, anything available on cloud is the mantra now, right? So with DWH, what has happened is the cost of adding more and more machines, right? And those machines need to be, like highly scalable, right? And because the complex queries that we run, right? It has to be, CPU intensive, and the storage and the computing for those resources is becoming more and more costly. So when the concept of cloud came into picture, data warehousing also thought about it, right? Because you need to scale up your resources, right? And the thing is, in a normal data warehouse systems, say if you're not using any particular computing resource, right? You've already paid the cost for it. So even if you're not using it, you still pay the cost for it, which is a total loss for you. Unlike in the case of the cloud, right? You pay for what you use, right? So that's the concept behind the cloud. And that's the secret why, many companies are opting for this cloud. So even during peak sales in your, Flipkart big million sale or all those sales, right? So you can even increase your resources during those specific sale time, right? And then you can scale up at that point of time. And once the festive season is over, you can again scale down. Everything happens, with just a simple click of a button. You don't need to procure those resources, and you spend a lot of time in that, right? So all those is, perhaps not happening now because of this cloud. So data warehousing also can be effectively used when moving to the cloud. So people started implementing the data warehouses in the cloud. So then came this concept of data lakes. This is also, a relatively new concept. So what happens in a data lake is, see, data warehousing stores only structured data, right? In a data lake, storage is the main factor, right? So you get data from different sources, be it structured, semi-structured, or unstructured, and then you put it in your data lake, just like a lake, right? So you put everything there, right? And then the ingestion process that we have, right? It is about getting data, whatsoever form it is, and then putting it into the lake, which I call it as the storing process. This storage is available of cheap of cost these days, right? That is why most of the DWH implementations are now also happening in the data lakes. And once the data is available in the lakes, the processing starts, okay? And then you do all your, here it is not ETL, and here it is the ELT, which is extract, load, and then you apply your transformations, be it data cleansing, aggregation, or your machine learning models, right? We have all those relatively new concepts gaining traction these days. So here the processing happens, and then it is consumed not only by the business users, okay, it can be consumed by the data scientist, who use these data to derive some models, okay, and it can also be, sending some information for building some APIs, okay. So the consumer part in a data warehouse has mostly been the business user. But here in a data lake, anyone can consume the data the way they want it. So that is one of the main thing that, DWH systems are now getting moved into the data lakes. So with the big data gaining popularity these days, right? You guys might also have heard about something called NoSQL. Initially, it meant NoSQL, and then it later got evolved into not only SQL, right? So SQL has always been the core of data warehousing, which means anyone, with not much technical knowledge also can query the database and get, some sense out of it. So this NoSQL option is never and ever going to replicate the data warehouse. Just that, it is going to support the diversified data set into the data warehouse. And the current data warehouse also must have some thought considerations towards the new cloud architecture that can, support growth in the data volumes and workloads. So what is the need that we are expecting for any modern data warehouse is it should definitely have the power of the traditional warehouse and the architecture of the cloud, and it should also use the flexibility of the NoSQL technology. So with this data lakes, right? So people thought data warehousing would no longer be useful, right? And then they got into this data lake. But even with data lake, what was happening is you were getting data from different sources and then storing it in the lake. But then you didn't know what to do with the data that you have, right? You have enormous amount of data, how to consume it, how to process the data. The governance rules are not being addressed in this case. Data warehousing is just, transforming and then loading, while data lake is loading and then you analyze the data out of it. So if you carefully look at both these cases, instead of doing it at the first step wherein I'm collecting all my data and then I'm transforming it into the way that I need, and then I'm loading into a data warehouse. While in a data lake, what I'm doing is I'm just loading the data and then I'm deciding how do I transform it so that I can consume it. So you're only postponing the problem to a later stage in the data lake. That still doesn't address the challenges that we are facing with the current problem. So if you look at this, right, we had this data warehouse in the 1980s where we had data from different sources, apply the ETL process, load it into data marts, and then, or your data, it could be your data warehouse as well, right? And then you have your business intelligence and reporting done out of this data warehouse, right? So this happened sometime in the 1980s time frame, while we slowly started, getting into big data, Hadoop, right? And then we had this data lake concepts, right? So where if you could see the structured, semi-structured and unstructured data, everything is put into a data lake. And then what you're doing is you're preparing the data, right? You're transforming the data. And if you look at the diagram carefully, you still have an ETL that is going to load to your data marts. So what you're doing in this case is you're having data in two different places, one in the data lake where it is the raw form, right? Whatever data you get, you are just loading into that lake. But then in the data mart, it is available in a much more refined form for analysis, right? So you have two copies of data, one in the lake and one in the data mart. So the one in the data mart will be used extensively by the team for making reports and dashboards, and the preparation data transformation phase, right? There you can have your data science and you can derive your machine learning models out of it. So if you carefully look at data lake, we are not eliminating the warehouse, we are just pushing the warehouse to a later stage, right? And the current trend that is gaining traction is the lake house. So we say lake house, what I'm doing here is, it is just a combination of both data warehouse and data lakes, but that you don't see, the data being duplicated here. Okay. And you have a transactional layer over this data lake, which both the BI team can be using it, which means that, what DWH would perform there, this transactional layer can handle it so that the BI team can be using it. And even your data scientist and machine learning models can be derived out of it. So this lake house is, relatively new concept. Okay. So it's, as I said it's an amalgamation of both these data warehouse and data lakes, but we still have a long way to go in the case of this lake house, because we just need to try it out. We just need to implement it and see, where it takes us. So what I would like to, derive out of this is data warehouse is not going to become extinct, but it is going to take different forms based on your data size and based on your cloud architecture. So even when we had data lakes, we still had data warehousing, but in a different form. And even when we have lake houses, we still use basic DWH in a different form that, it could be consumed by the business intelligence users, right? So that's the end of this session. And I would be happy to take any questions in the chat window.
Thank you, ma'am, for giving your valuable insights about data warehousing. Participants, this is the time to solve your queries.
So Kirtana has come up with a question asking if there is any algorithm available. So there is no specific algorithm, Kirtana. It all depends on your organizational needs, right? And you need to derive algorithms based on your organizational needs so that you can build up your data warehousing. We don't have anything specific with respect to that.
சரி க்ளோஸ் பண்ணிடலாம்.
பண்ணிடுங்கம்மா.
Kirtan again asked, what languages are used in TWH?
It's not about languages, Kirtana. So, see, framework has this MapReduce technology which uses Java. Okay, but I wouldn't restrict it to any specific language. You could the question could have been like, what are the tools to be used for DWH, right? So we have quite a variety of tools available in the market, like Informatica. You have Essential data stage. Okay. So those were. Sorry, I'm able to hear what. Can you please go on mute? Okay. Thanks for that. So the tools available are earlier for the traditional data warehouse implementation. Customers have been using Teradata, Informatica, and Essential Essential data stage, and so on, right? And for the current data lakes, right? So we have tools from Azure, which is the Microsoft, and Amazon data lakes. Okay, and architecture is what I mentioned, that different approaches, top down or bottom down approaches that can be used for data warehousing. But the basic architecture is extracting data from different sources, transforming it, and then loading it into a warehouse. It could be an EDW, which follows the enterprise data warehouse, or a data mart, and then a BI layer will be built on top of that DWH, based on which you can have reports and analytics done. So hope that explains. Yes, definitely. Again, Kirtana, is coding required? Yes. You never know, right, what logic you're going to apply for any transformation that you're going to do, right? So you might even want to write Python scripts, right? I'm just thinking aloud here, right? Coding is definitely required for any ETL, because you need to ingest data into your system. So you're going to get data from different sources as well. You might as well use a tool. So we have many tools for that, right? Talent, Informatica also comes up with a tool to ingest data. Or there might be cases, right, where the customer might be having some specific files from which you need to take data out of it, right? So you might want to, apply some logic and build the code over there. Or it be in the transformation layer as well, right? Mostly it would be in the transformation layer, wherein you have to, aggregate data or cleanse data. Cleansing is another area where there are tools available in the market as well for data cleansing. But yes, at some point you might want to require, in case if you require logic, right? So you might want to code as well in that area. So transformation is a place where we come up with business logics. So we definitely, need to be able to code in that stage. Why ETL is important in DWH? Okay. See, without ETL, the DWH would not even exist, right? So how do I build a DWH? Only if I get the data from different systems and if I transform it and load it, right? Only then I'll get data in my analytical systems. I cannot use the data that is already available in the transactional databases, right? See, I want to do some analysis and I'm going to use the OLTP systems databases, right? I will also be querying, and at the same time, the existing users of it, right, would also be querying the databases. Just imagine that, you are withdrawing amount from a bank, and at the same time, the manager of the bank, wants to decide on coming up with a new savings plan, right? He is also going to query the database. If everything existed in one place, right, which one is more critical here? The is it for the business decision, or is it for the user, that is wanting to update the account, right? So the priority is for the user and not for the business user here, right? So in that case, if I query and if that guy also hits this database at the same time, there will be more load, right? And it would be unable to handle the load. Just don't think of it as, two users hitting the systems, right? There will be n number of users hitting the system in a real-time case. So if the load of the system becomes more, right, we need to prioritize, and only then we need to, query, right? So in that case, we would definitely want to separate an OLTP systems from an OLAP system. So that is where this ETL comes into picture, because without extracting, without transforming, you cannot load the data anywhere, and you cannot use your transactional database directly also, right? So yes, ETL is very important in a DWH setup.
Thank you once again, ma'am,
Yeah.
for your interactive session and patiently answering students' queries. It is my privilege to invite Mr. R. Balamurugan, Assistant Professor, Department of Computer Science, Vistas, to propose our thankfulness.
Thank you, madam. Thank you, madam. Yeah, very happy morning to all. It is a great pleasure for me to deliver vote of thanks on behalf of management, staff, students of School of Computing Sciences, Department of Computer Science, Vels Institute of Science, Technology and Advanced Studies. I extend my sincere thanks to our Chancellor, Vice Presidents for their continuous support and encouragement to organize such type of event in a regular interval. I express my sincere thanks to Vice Chancellor, Registrar, Controller of Examination for their guidance that help us to conduct this event in a successful manner. I tender my gratitude to Director and Head of the Department of Computer Science, Dr. P. Mailwakanan, for initiating us to encourage and organize this event. It is my duty to spell my sincere thanks to the coordinator, staffs, and students of computer science for organizing this webinar. I convey my sincere thanks to Madam Alamelu Diagarajan, Director EC, for spend her valuable time with us and share their knowledge to our students. Thank you, Madam, for accepting our invitation and give a nice presentation. Finally, I express my sincere thanks to all the participants for their active involvement. Once again, I thank all for the successful completion of this webinar. Thank you. Thank you, one and all.
Thank you all. Thank you, ma'am.
Thank you. Thank you. Thank you, guys.
Thank you, ma'am.
Thank you.
Thank you.
Bye. Bye. Bye.